So, good afternoon to everybody. Now, today's topic will be focusing on the modern instruments and detection of chemical agents with the help of these instruments. It is very much evident that all the CBRN agents and equipments cannot be assessed very easily with the help of any normal equipments. It required specialized equipments which should detect the impact of chemical, say biological, radio, and nuclear agents. But yes, it requires specialization. And herein, as an first responder, we would like to see something which is much required for the instrumentations and detection part of chemical agents. When we are able to understand certain instruments and detection mechanism, up to some extent, we can easily assess how to detect, how to analyze the agents present in the chemical domain or chemical part. So it would be a good thing to understand the detection mechanism, and we will see how. So as we all know that it can be quantified in two parts: chemical agents uh, and toxic industrial material detections. Chemical agents can be detected by several means that incorporate various technologies. So on a broader note, all the toxic industrial materials or say chemical agents have been bifurcated into five main technological points. First is the point detection. We will learn one by one. First is the point detection. Second is standoff detection. Third is analytical instruments. Fourth, solvent sampling. And last is the colorimetric, that is color change. So the type of technology needed for chemical agents and the toxic industrial material detection will be dependent on the type of chemical agents or the toxic industrial material used and the objective of the first responder unit. So it is very evident that we have to understand these things that okay, we have certain types of detection mechanism or technologies which we can use for detection mechanism. But yes, depends on the conditions and how to see when to see is also much required. Why? Because certain type of chemical agents may require colorimetric test. Some will be focusing upon the sorbent sampling, and some will be utilizing point detection. So it depends on the agents, whichever is there, and how to assess is also a big important thing, an important parameter in detection of an agent or the properties of agent. As we all know that we have learned something about the properties of agents for chemical, say biological, and we know that different type of agents shows different type of properties. Some will attack on nervous system, some will be focusing upon the toxic fumes formation, some will focusing upon the belief formation. So it depends how to focus upon. So similarly for the detection part also, they will show different type of properties, different type of parameters, and it requires different type of analytical skills or analysis, which will be very much helpful for all these parts. So we will take one by one. First, we will take point detection technologies. So as this is the first technology, we have to focus upon this particular part. Point detection technology is applicable in determining the type of chemical agent or toxic industrial material employed and can be used to map out contaminated areas if enough time is available. So it is very clear if you see upon this particular slide that time management is much required. If we have enough time, if we go for the example part, certain incident took place, but it is not creating problem in the neighborhood or community or stakeholders not complaining anything, then it is very clear that we can focus upon this part. We can take the utilization of point detection technology. It can be used as warning devices to alert personnel to the presence of a toxic vapor cloud. So if this type of detectors are available, we can easily see that okay, downwind velocity is say 40 meter per second or say 4 miles per hour, whatever is the mechanism, we can easily say the first responders that after a few minutes or few seconds, similarly as we see the wind direction, that okay, this type of wind is going to come. You have seen in the cloudy seasons or the winter seasons that whenever there is a say snowfall in hilly areas, then impact is on the ground areas is there. Similar case of thing is here also that we can understand. In this scenario, wherever the alert mechanism required, the detector is placed up wind of the first responder's location. So wherever is the first responder, we can easily say when the toxic chemical is carried towards this location, it first encounters the detector, thus sounding an alarm, allowing the first responders to don the necessary protective clothes, or to take or use, utilize, or wear the necessary protective clothing. So whenever this type of technology is being used, it is very easily that understood that it would really help the first responders for the say alarm situation is there, and it would easily detect what type of alarm is required. It should also be noted that if the concentration of chemical agent or toxic industrial material is high enough to be immediately life-threatening, point detectors maybe provide sufficient time to take protective measures. So these are certain points which is very much required. It will also provide it will hepatitis may not provide sufficient time to take protective measures. So again, depend on the concentration is also a big say lacuna or say true thing. If the concentration is up to certain extent, then it would be very helpful. But when it goes beyond certain concentration or it is on high concentration, then this technology may not be very helpful and may not provide sufficient time to take protective measures for the first responders. Another use of the pond detector would be to monitor the vapor contamination originating from a decontamination site. Okay, it's a very big thing that we have to focus upon vapor contamination. Certain thing come into the ambient environment after a few minutes or a few seconds. It has started generating certain vapors or this sort of thing. This also we have to focus upon that. And use of pond detector would be monitor the vapor contamination. It can also be used to determine which people have been contaminated. It is contamination triage. So again, with the help of this detection, we can easily ascertain that okay, this type of people or this group of bunch of people have been contaminated, and we can easily go for the contamination triage. Triage, you all know, the bifurcation of the victims at any site or incident site wherein we requires to ascertain which is more contaminated, which requires immediate help, which requires delayed help. So this type of thing is also done by the bond detector mechanism. And as is quoted here, contamination triage can be used to identify highly contaminated personals, lightly contaminated personals, and uncontaminated personals with the idea that all contaminated people need rapid decontamination, while non-decontaminated people do not need to be decontaminated, thereby saving resources. So when this technology be used, we can bifurcate on an easy note, and we can easily process the support mechanism or recovery mechanism to the required personnel rather to wait for that to who is not a victim, then also we focus on that part. So it is much required that this technology can be used for contamination triage. These are technologies, see, it is very clear that first responders are the persons who are mostly victim because they are helping it out. They are near the communities, so they at the incident site. There is a probability that they are more contaminated in compared to some other group or bunch of people. So this is very much evident that we can focus upon this part too. Consumption triage. Now, next, in what type of spectroscopy we can use? So in point detection technology, we have certain technology called as ionization or ion mobility spectrometry, that is IMS. The figure is quoted over here. You can see this figure very easily. You can see this figure. This figure is APT 2000. This is manufactured by Environmental Technologies Group Incorporated. Again, now understanding this type of technology spectroscopy, it is a detector using IMS technologies in typically a standalone detector that uh, samples the environment using an air comb. Contamination is the sampled air are ionized and pass through a weak electric field towards an ion detector. Time it takes to specify to traverse the distance is proportional to the mass of the ionized chemical uh, species and is used as a means of identification. So very easily understood. The time is the important parameter, and takes to traverse the distance is proportional to the mass of the ionized chemicals. This is the main heart of this particular thing. Analysis time ranges from several seconds to few minutes. Ionization of gaseous species can be achieved at atmospheric pressure. Using proton transfer reactions, charge transfer, dissociative charge transfer, or negative ion reactions, such as ion transfer, nearly all chemical classes can be ionized. So basically, you can understand the word ionization. This is the main crux, and we are understanding this particular spectroscopy with the terminology ionization. However, most IMS portable detectors use radioactive beta emitters to ionize the sample. So we have to simply understand upon the sampling mechanism. This is very easy to understand that which type of sample is used. So it is very much required. When we go for this particular technology or say ionization, again we have to understand that it is only a process by which an atom or molecule gains or loses electrons, resulting in a negative or positive charge. So ionization is the basic crux or the principle by which these mechanism is being used. And if an atom or a molecule gains an electron, it becomes negatively charged, and if it loses an electron, it becomes positively charged. Energy may be lost or gained in the form of an ion. So the distribution of energy is the basic mechanism by which this particular spectrometry is being done and being understood. So this is a figure which we can focus upon, that being very easily used, that is APD 2000. This type of mechanism machines is very easily in the market also. Another example is M8A1 automatic chemical agent system. This is a figure by which we can analyze the impact of chemical agent. It incorporates the M43A1 detector to detect the presence of Norwegian vapors or inhalable aerosols. It is again detection is an ionization product, diffusion or ion mobility type detector. Air is continuous drawn through the internal sensor by a pump at a rate of approximately 1.2 liter per minute. Here and agent molecules are first drawn post a radioactive source, and a small percentage are ionized by a beta rays. The air and agent ions are then drawn through the baffle section of the cell. The lighter air ions diffuses to the walls and are neutralized more quickly than the heavy agent ions that have more momentum and are able to pass through the baffled section. Sorry. As a result, the collector senses the greater ion current when nerve agents are present compared to the current then only clear in sample. So this you can see this the collector senses a greater ion current. So when a sensor senses greater ion current, then the probability of nerve agent is there. If the system is vice versa, then it is not there. Again, an electronic module measures the current produced by the sensor and triggers the alarm when a critical threshold current is reached. So this is a very small basic mechanism: diffusion plus a greater ion current exchange. So the collector senses a greater ion current exchange. Then by this mechanism, it is able to understood that okay, there is a chemical agent and it alarms and give the first responders or whosoever is handling this mechanism the understanding. Okay, there is a probability of a Norwegian vapor or inhalable aerosol is present in the ambient atmosphere. Detection is the basic thing we are able to detect. Then we can proceed with the help of proper antidotes or mechanism required for this particular thing. Now, the next in particular, this series is flame photometry. Flame photometry is based upon burning ambient air with hydrogen gas. So, if you somebody asks you what is the basic principle, you can easily say burning of ambient air with hydrogen gas. So, when it is being the flame decomposes any chemical agents or toxic industrial materials present in the air. Compounds that contain phosphorus and sulfur produce hydrogen, phosphorus, oxygen, HPO, and elemental sulfur as respectively. So the mechanism is this only. With the help of this mechanism, you can easily ascertain that okay, burning is there. What will be the release? They will release HPO, hydrogen, phosphorus, oxygen, and elemental sulfur. So with this mechanism, they can easily ascertain what type of agents are there. At the elevated flame temperature, the phosphorus and sulfur emit light of specific wavelengths, again, which will give us a direction. Okay, this type of wavelength shows this type of chemicals. A set of optimal filters is used to selectively transmit only the light emitted from the purpose of phosphorus and sulfur to a photomultiplier tube, which produces an analog signal related to the concentration of the phosphorus and sulfur containing compounds in the air. So this signal basically says, okay, this time this amount of concentration of phosphorus and sulfur is available in that particular sample. Since the classical nerve agents all contains phosphorus and sulfur and mustard contains sulfur, these agents are readily detected by flame photometry. So with this, we can easily understand that what type of material is there, because phosphorus and sulfur is quite abundant in any type of agents. It is a sensitive and allows ambient air to be sampled directly. However, it is also prone to false alarms from interference that contains phosphorus and sulfur. So you cannot say that okay, only the agents have particular this type of thing, but yes, there could be a probability of flame false alarms in flame photometry. The number of false positives due to interference can be minimized using algorithms, and using a flame photometry detector in cooperation with a gas chromatograph will further reduce likelihood of false alarm. So again, it's a very good technology or mechanism to understand which type of chemicals or chemical agents are produced, because it decomposes any chemical agents and the ions present in the air. Next in the series is infrared spectroscopy. It is the measurement of the wavelength and intensity of the absorption of mid-infrared light by a sample. So whenever we take the sample, we focus on the absorption, how much it is being absorbed. Mid-infrared light means 2.5 to 50 micrometer and 4000 to 200 centimeter, 200 per centimeter is energetic enough to molecular vibrations to higher energy levels. So spectroscopy wavelength is there, then frequency, intensity type of things is there. So it focuses upon the excite molecular vibrations to higher energy levels. The wavelength of infrared absorption bands are characteristic of a specific type of finger bonds, chemical bonds, and every molecule has a unique IR spectrum or fingerprint, similar type of our focus. So this type different type of band lengths are there, wavelengths are there. The IR infrared spectroscopy use all these things. Again, IR spectroscopy finds its greatest utility for identification of organic and organometallic compounds, which can be used for as a potential chemical agent. There are two infrared spectroscopy technologies employed in the monitors. First is the PIRS, that is photoacoustic infrared spectroscopy, and the second is filter-based infrared spectroscopy. These two technologies are and specific detector examples are discussed in the remainder of the section. So we will focus upon in the next thing what type of technologies is being used. So now PIRS, photoacoustic infrared spectrum, we have seen the two. The first we will focus upon the photoacoustic infrared spectroscopy, how it works. Again, photoacoustic detectors use the photoacoustic effect to identify and detect chemical agent or vapors. It will focus upon the agent vapors, whichever is required. When a gas absorbs infrared radiation, its temperature rises and in turns the gas to expand. This is a basic mechanism where whenever there is an infrared radiation, again it's a form of increase in temperature only. So temperature rises and turns causes the gas to expansion phase. If the intensity of the infrared radiation is modulated, the sample will expand and contract. This is a basic mechanism. If the modulation frequency is an audible frequency, a microphone can be used to detect the resulting sound, or photoacoustic gas detectors use various filters to selectively transmit specific wavelengths of light that are absorbed by the chemical agent being monitored. The great number of wavelengths used to identify the unknown, the fewer inference will be observed. And when no chemical agent is present in the atmospheric sample, the specific wavelength infrared light is typically not absorbed, and therefore no audible signal is detected. So it is very much required that the modulation or the change in the song it should be noticed. And how to notice? Again, it requires some type of material which should be there. If there is no such audible signal, then the probability of chemical vapors or agents is very low. When chemical agent is present in the sample, an audible signal at the frequency of modulation is produced by the absorption of modulated infrared light. Selectivity can be increased by sequentially exposing the sample to several wavelengths of light. So you can easily see that this type of chemical agent vapors can be used for the photoacoustic effect. Again, the effect is very clear that we have to focus upon the number of wavelengths. Okay. So if we are not getting any audible signal, then we can say the sample is free from any agent. If you're getting some audible signal, then it is the probability of agent in this zone. Chemical agents are distinguished from interference by the additive signal produced when several different wavelengths are sequentially transmitted to the sample. So this is thing we directly send or supplies the signals in every way, and we can say that it is being used. Photoacoustic detectors are sensitive to external vibrations and humidity. So again, this parameter should be taken into care that whenever we use these detectors, sensitivity from external vibration should be taken care of, and it is very much required that we have to focus upon this particular part. So when we focus upon all these things, it is very much required that we understand the several other properties. So when we focus upon this particular thing, that's talking about all these parameters. For example, we are focusing upon the photosensitivity, though we have to understand what is photoacoustics effects. Again, it is a effect, or we can say is a phenomenon that occurs when light absorbers in soft tissues generate ultrasound waves. This is the only this thing. The effect occurs when material absorbs light, causing sound waves to form. It absorbs the light and sound waves will form. This is the only mechanism which is being used or utilized for photoacoustic detectors. This is the only mechanism. However, as long as the detector is calibrated in each operating environment immediately prior to sampling, selectivity will be very high. A mobile laboratory, you can see this type of this thing. It is a meter. because it is the Innova Type 1301. It is basically mobile laboratory. A similar portable unit is 312. You can see here 31131. Both have the same mechanism. They are just sending the signals and generation of the conversion of say energy into one form. This is a conversion energy from one form to another, or you can say light being absorbed and generation of waves. Light absorbed and generation of waves is the basic mechanism of multicast monitor. These are two figures which we can see can be used for this particular thing. Now come to the next, filter-based infrared spectrometry. The filter-based infrared spectrometry technology is based upon a series of lenses and mirrors that directs a narrow bandpass infrared beam in a pre-selected path through a sample. Figure is here, Myron Cepheid portable ambient air analyzer. Again, you can see this type of figure. It is very easily available. The amount of energy absorbed by sample is measured and stored in memory. How much amount is being absorbed? It is the basic crux. The same sample is examined at as many as four additional wavelengths. This multi-wavelength, multi-component data is analyzed by a microprocessor utilizing linear matrix algebra. Concentration of each component in each sample at each stations are used for compiling time-weighted average reports and trend displays. The DMCS retains data for further analysis and longer terms and retrieval. The Foxborough company produces two of these reactors. First is the Maran Sapphire, a portable ambient energy, and Myran 981B, a multi-point ambient air monitor system. So this is the basic mechanism. You can easily say absorb the amount of energy absorbed by sample is measured and stored in memory, and same sample is examined as managed for different wavelengths. So we can focus upon these two parts, and you can easily analyze filter-based infrared spectroscopy. Next point is electrochemistry. Electrochemical reactors monitor a change in electric potential of a solution or thin film when a chemical agent is absorbed. This mechanism basically absorption of a chemical agent, and focus upon this particular part. We have to focus upon this thing. Huh. So, so when we say about this particular node, electrochemistry or say electrical reactors, again it basically use a relationship between electrical potential difference and chemical change. What is the electrical potential difference and chemical change? This is a basic funda. Example of one-type reaction is inhibition of cholinesterase by nerve agents. Solution containing a known amount of cholinesterase is exposed to an air sample that may contain nerve agent. If nerve agent is present, a percentage of cholinesterase will be inhibited from reaction in the next step. So this particular amount of material is being used for understanding how much is the required district. The next step involves adding a solution containing a compound that will react with uninhibited cholinesterase to produce an electrochemically active product. The resulting cell potential is related to the concentration of uninhibited cholinesterase, which is related to the concentration of nerve agent present in the sampled air. So again, this mechanism can be very easily used, and if it is present, a percentage of cholinesterase will be inhibited from reaction to the next step. So next step, we see this particular, we have already added this particular cholinesterase, and the next step we analyze, okay, it is present or not. If the process continued, it will be shown that cholinesterase is exposed to an air sample and it contains a nerve agent. So you can easily understand this particular thing also. And this is the next phase. Fourth is colorimetric. So we have already seen five. The last one in the series is colorimetric or color change chemistry. Detect kits or tickets are wet chemistry techniques formulated to indicate the presence or absence of a chemical agent by a color change resulting from a chemical reaction involving the suspect agents. These kits are usually used to verify the presence of a chemical agent after an alarm is received from another monitor. The kits are also used to test drinking water contamination. It's a big tool. A similar detection method using this technology is detection paper, which contains a dye that is colorless when crystalline and colored and when cyanide color when dissolved in a chemical agent. Detector papers or vapor are generally used for testing suspects droplets or liquids on a surface. For gaseous and vaporous chemical agents, colorimetric tubes are also available. These consist of a gas tube that has the reacting compound sealed inside. Upon use, the tips of the tubes are broken off and a pump is used to draw the sample across the reacting compound through the tube. And if a chemical agent is present, a reaction resulting in a color change takes place in the tube. So whenever there is a color change, you can easily ascertain that there is a chemical agent in this particular sample. And this is the only basic. The change in the color is took place in the tube, and it will tell us that okay, there is certain amount of agent present in this particular samples. Colorimetric is basically a color change chemistry. Certain more things: surface acoustic wave (SAW). Surface acoustic wave detectors consist of piezoelectric crystals coated with a film designed to absorb chemical agents from the air. Surface acoustic wave detectors are used 2 to 6 piezoelectric crystals that are coated with the different polymeric films. Each polymeric films preferentially absorbs a particular class of volatile compound. For example, one polymeric film can be designed to preferentially absorb water, while other polymer films are designed to preferentially absorb different types of chemicals such as trichloroethylene, toluene, ethylbenzene, or formaldehyde. So, depends on the class of film that what it is meant for. The piezoelectric crystals detects the mass of chemical vapors absorbed into different chemically selective polymeric coatings. Change in the mass of the polymeric coatings causes the resonant frequency of the piezoelectric crystals to change, and by monitoring the resonant frequency of a different piezoelectric crystals, a response pattern of the system of a particular paper is generated. This response matter is then stored in the micro process. So this type of things is very much evident, and it is being used for surface acoustic waves for analyzing the chemical agent present in a particular group of samples. When the system is operating, it constantly compares each new response pattern to stored response pattern for target paper. When the response pattern for the target paper matches the stored pattern, the system alarm is activated. The selectivity and sensitivity of these detectors depends on the ability of the film to absorb only the suspect chemical agents from the sample layer, and many SAW devices use pre-concentration tubes to reduce the environmental interference and increase the radiation sensitivity. This is an example which I can show you here. A detector manufactured by Microsensor Systems Incorporated that is based on the SAW technology is a SAW Minicat 2 its name. So you can easily see that there are certain systems which is utilizing this type of microsensor systems wherein technology is being utilized. Response pattern is the basic thing. Response pattern is being changed. We can suspect the chemical agent in the sample. Response pattern is the same. Then it is okay that the sample might not contain any type of chemical agent. So this is very much required. Next, photo ionization detection. Again, it's a technology for detection part. Photo ionization detectors works by exposing a gas stream to an ultraviolet light of a wavelength with energy sufficient to ionize an agent molecule. If agents are present in the gas stream, they are ionized. An ion detector then registers a voltage proportional to the number of ions produced in the gas sample and thus concentration of the agent. So you can easily see concentration plus ions produced is very much required for ascertaining the agent present or not present by utilizing photo ionization detection mechanism. Specifically of these detectors is a function of how narrow the spectral range of the exciting radiation is and on how unique that energy is on ionizing only the molecule of the interest. Two examples I have quoted here: Mini Ray Plus and Photo WAC 2020 PID monitor. These are portable detectors which can be taken very easily to the site where there is thing. They are using just photoionization effect and understanding that agents are present in any gas stream or not, and depends on the detection mechanism or sampling of this mechanism, you can easily quote, okay, this type of material present and this is not present. Next, eighth one is sensor array technologies, SAT. Sensor technology is based on upon the use of an array of different chemical sensors such as conductive polymer, metal oxide, bulk acoustic waves, SAW we have already seen devices, and simultaneously for real-time monitoring. So you can easily say it is using different types of say waves also, polymers also, metal chemical side also with real-time monitoring. The various sensors that are used must respond rapidly and reversibly to a chemical vapors they are exposed to. This technology is used in instruments commonly known as electronic noses. You can see this figure. It is a mobile laboratory detector that is based upon ST sensor array technology in the EV eNose 5000 electric nose. So this technology is again based on the array of several chemical sensors. We can see the n number of sensors in this particular figure, and they're utilizing this thing on a very small greater node. Next is thermal and electric conductivity. Thermal and electric conductors are used metal oxides. Thermal conductivity metal oxides, thermal conductivity semiconductors that measure. The focus is that utilization of metal oxide thermal conductivity semiconductors that measure the change in heat conductivity that occurs as a result of a gas adsorption on the metal oxide uh, surface. So it is basically focused upon the mode of heat transfer. There are three: conduction, convection, and radiation. So it is generally using the conduction mechanism, means transfer of heat through a solid medium. So this is the basic mechanism they are utilizing, and it is a result of gas adsorption on the metal oxide surface. Also, the change in resistance and electrical conductivity across a metal foil in the system is measured when a gas adsorbs onto the surface of a metal film. So adsorption again is a mechanism. Contaminants in the atmosphere being measured and will result in measurable electrical differences from the clean and background atmosphere. Additionally, different contaminants will have different thermal conductivities and therefore different electrical responses from thermal and electrical conductivity detectors. So all these things to be very easily understand that okay, it requires certain parameters, but differentials are there, and depending on the differences and additional properties, we can easily ascertain the presence of chemical agents by utilizing thermal and electrical conductivity, as I have already quoted about the conduction mechanism. Next is flame ionization. Flame ionization. It's against the technology ionization we are understanding. A flame ionization detector (FID) is a general purpose detector used to determine the presence of volatile carbon-based compounds that are incinerated in a hydrogen-oxygen flame. So hydrogen-oxygen flame is being used when the carbonaceous compounds burn. An increase in the flame's baseline ion current takes place and detection of a compound occurs. Flame ionization detectors are not specific and require separation technology for specificity, such as gas chromatograph. Identification of compounds is generally determined by comparison of a compound's chromatographic retention time of that to that of a known standard, or to chromatographic retention indices for a series of known compounds using a standard set of chromatographic conditions. It is already established conditions which we use to analyze samples being taken, and already analysis of all this thing is there. It is handheld FID, the micro FID for the non-specific determination of flammable and potential hazardous compound in the concentration range of 0.2 to 50,000 ppm. You can see this type of mechanism there, and it is already established protocols or say data where we have to correlate with the data present, and we can easily understand okay this type of sample result analysis is being understood. Next is standoff detectors, or it uses again infrared spectroscopy. Standoff detectors are used to give advance warnings of a chemical agent cloud, as we have seen in case of boiling liquid vapor explosion, expansion, boiling liquid expansion, vapor explosion. We can easily say cloud is being formed. So it is a basic advanced warning mechanism. This type of detectors typically use optimal spectroscopy and can detect chemical agents at distances as great as 5 kilometers. So, with the help of this detector, we can easily say we are infrared. You know, the wavelength of infrared is too much, and infrared is being used for understanding. Agent-free spectra must be used as a baseline to compare with freshly measured spectra that may contain chemical agents. So again, it's a comparison type of thing where it is being used. Standard detectors are generally difficult to operate and usually require the operator to have some knowledge of spectroscopy in order to interpret results. Available standard detectors are infrared spectroscopy with either passive or active sensing. So this is a small technology which is being used. Again, infrared is there in the atmosphere. It is being used for the analyzing the result. It is being thrown, and you can, as I quoted over here, it can detect the chemical agent to a distance of 5 kilometers. So for this range, we can use standard detectors or infrared spectri to ascertain is there a chemical agent present or not in the ambient atmosphere. Next, passive type of technologies on what we call as passive detectors. That means FLIR and FTIR. First, forward looking infrared, and next is Fourier transfer infrared. It's again being used in detection of agents or say chemical or hazardous material in the atmosphere. Passive standard detectors collect infrared radiation emitted or measure infrared radiation absorbed from the background to detect chemical agent and toxic industrial material vapor clouds. So this type of technology we use forward-looking infrared or Fourier transfer infrared. We will not go into depth, but on a understanding way, passive standard detectors employ one of two infrared spectrum technologies. First is forward-looking infrared imager, and second is Fourier transform infrared FTI spectrometer in order to collect the infrared radiation. So this is the basic collection mechanism. Infrared radiation is being collected. The difference between the two is then how they process the infrared radiation, and FLIR spectroscopy uses a series of optical filters, whereas FTI spectroscopy, Fourier transform infrared spectroscopy uses a interferometer. So two type of differences there. This use series of optical filters and it uses interferometer for analyzing the data or the collection sample mechanism. Next, active differential absorption LiDAR. LiDAR is light detection and ranging LiDAR. LiDAR is the laser analog to radar. In LiDAR, a pulsed laser beam is sent out to a target object. If there is a material which is being contaminated, or there is a say sample which is being contaminated, then we use not going with the conventional mechanism. We just throw a light detection and ranging mechanism, or we just send a pulse beam to a target object. Some of the light that is incident on the target is reflected back to the sender, and the rest is scattered, reflected, and transmitted or absorbed by a medium. So this is the basic mechanism whenever light is being thrown or coming to a surface. This is a missile scatter, reflect, and transmitted or absorbed by the medium. The time it takes for the light to travel from the sender to the target and back to the sender is used to calculate the distance to the target. For studying clouds in the atmosphere, differential absorption LiDAR can be used to measure both the range of the cloud and concentration profile of the cloud. In differential absorption LiDAR, two laser beams of slightly different frequency are used to analyze the cloud. So if you say the basic mechanism is this only, we calculate the time it takes to light travel from the sender to the target and back to the sender. It is being calculated the distance, and then we can easily say, okay, this type of already fixed set of data is there. If it is coming in this time or it is reflect going back in this time, then we can ascertain this is particular mechanism shows for a particular group of chemicals or say agents. One of the frequencies is tuned to a molecular absorption of one of the molecules in the cloud. This requires prior knowledge of the cloud composition. So already, as I quoted, set protocols is there and the set data is there. The intensity of the reflected beam is a function of the amount of laser light absorbed by the cloud. This is related to the concentration of absorbing molecule in the cloud. The cloud does not absorb the second frequency, and since its frequency is similar to that of the first laser, it will have similar reflection and scatter profile. Thus, the difference in the intensity of the two reflected beams will be due to absorption of the first laser beam of the cloud. The intensity of the return signal from the second laser beam is used as a baseline for calculating concentration of the cloud. The time it takes for the two lasers to reflect back to the sender is used to calculate the range of cloud. So whenever you calculate all these things, we can easily understand that then data is useful for tracking a chemical agent cloud once it has been identified, but typically cannot use to identify chemical agent cloud. So we can ascertain up to a certain extent that this mechanism is being thrown to a sample already to recently far place and understand this thing. Next are the analytical instruments. The analytical instruments described in section can be used to analyze samples as small as a few microliters or milligrams. They are designed to differentiate between accurately measure the unique chemical properties of different molecules. These instruments are quite sophisticated in order to detect and differentiate subtle differences between trace amounts of different molecules. Accuracy and reliability requires that only pure reagents are used and that very rigid protocol and operating procedures are followed. This typically precludes their use outside of a laboratory equipment that is staffed by technically trained people. However, some analytical instruments have been developed for field application also, but generally it is placed in the lab is only. So it is very much just established over there. Additionally, the instruments do not display the measured data in a straightforward manner because it is a, as the name itself suggests, analytical. Their interpretation of measured data typically requires a technically background and access formal training. So it generally instruments give some data, but it requires certain type of capability, technological capability, which I could say to ascertain which type of detection has been shown and which type of material is being used in this particular domain. So it is being used in that way also. Next is you have learned this terms spectroscopy. Mass spectroscopy is a technique that can positively identify a chemical agent at a very low concentration. Those who are from chemistry background can easily understand the mass spectroscopy, and even they have done this particular thing in their particular labs and focus on that part. So again, it is basically when we talk about the mass spectroscopy or spectrometry. So this is very much related to certain uh, things which requires the data analysis of identify a chemical agent at very low concentration. So again, it is analytical technique that measures the mass to charge ratio of ions. The results are presented as a mass spectrum, which is a plot of intensity as a function of mass to charge ratio. So in this technique, it is a technique that can positively identify chemical agent at a very low concentration. In this technique, a volatilized sample is ionized typically by an electron beam, which also causes the molecule to fragment into smaller ionized pieces. The ionized molecules fragments are then passed into a mass analyzer that uses electric fields to separate the ions according to the ratio of their divided by the electric charge. The analyzer allows only ions of the same mass over charge ratio to impinge upon the detector. The analyzer allows only ions of the same mass over charge ratio to impinge upon the detector. By scanning the electric potentials in the mass analyzer, all the different mass or charge ions can be detected. The result is a mass spectrum that shows the relative amount and the mass of each fragment and the unfragmented parent molecule. Since each molecule forms a unique set of fragments, mass spectroscopy provides positive identification. It is very easily used in the labs when we have to analyze on the sample is volatile and all these things with their electron beam. To simply interpretation of a mass spectrum, it is best to introduce only one compound at a time. This is often achieved by using a gas chromatograph to separate the components in the sample. The end of the gas chromatography column is connected directly to the inlet of mass spectroscopy. So you can see here it a field portable system where a responder is taking the data over there and the help of spectrometry he is analyzing the data, and this is again Agilent 6890 gas chromatograph is using this particular technology to ascertain the data present in this. So all these things are very evident, and we can easily see the requisite information details for the particular zone. So after mass spectrometry, we have gas chromatography (GC). The gas chromatograph uses an inert gas to transport a sample of air to long chromatography column. Each molecule sticks to the column with a different amount of force and does not travel down the column at the same speed as the carrier gas. This causes the chemical agents and interference to the come out at the end of the columns at different times, called retention time. Since the retention time is known for the chemical agents, so it is very clear that it is uh, already known. So we can easily say the incidence time is unknown to the chemical agent. The signal from the associated detector is only absorbed for a short period, starting before and ending just after the retention time of the chemical agent. This eliminates false alarm through similar compounds that have different retention times. Using a pre-concentrator specific to the analyze can also reduce false alarms and caused by interference. So you again would like to ask about the terms interference. Again, it is basically a substance that can interfere with an analytical procedure and produce incorrect results. Interference is there. I talk about the engineering part. It is in a material condition that can affect the true measurement or target the gas concentration. So this is basically a middle type of thing which say changes the result at its own. The pre-concentrator passes air through an absorbent filter that traps air in molecules. The filter is then isolated from the air and heated to release any chemical agent that may be trapped. The released chemical agent is then pumped through the column and reactor. It is the Perkin Elmer Voyager, and this is again an analyzer which uses this particular mechanism or chromatograph detection mechanism. Next is HPLC. It's again a common terms which you have seen. The full form is high performance liquid chromatography. High performance liquid chromatography is most useful in the detection of identification of larger molecule chemical weights in such as BZ or LSD, and in the detection or identification of biological agents. With a high performance liquid chromatography, those compounds do not uh, those compounds that do not easily volatile can be analyzed without undergoing chemical divergence and sorry, derivations. As the gas chromatographs HPLC, high performance liquid chromatography instruments can be equipped with the variety of detectors such as ultraviolet visible, UV dust spectrometers, mass spectrometers, fluorescence spectrometers, and electrochemical detectors. You can see a huge amount of analysis can be done by this, but again, it is the most advanced, say, technology which is being used. So it is very important to understand that this type of group is focusing mainly upon the particular groups. Two limitations of the fielding the HPLCs and the literature are the need of power requirements. It requires 120 volt horse current and high purity solvents. So we can focus upon this and talking about the say BZ or LCDs. Both are the important parameters and type of CNS represents. LSD again is lysergic acid diethylamide, or you can say is cannabinol. Again, it is first candidate for this group as of CWS, which we required. So this technology is being used, and it also identifies some biological agents. Also, we're talking about the HPLC, not about the chemical. It also ascertain and find out the chemical agents present in any sample. There are a few examples which I try to show. Hewlett Packard has developed HP1000 HPLC system, then Perkil Elmar Turbo LC plus HPLC systems, Shimadzu LC10 HPLC system, and Varian ProStar Analytical HPL systems. In the market, there are a number of HPLC systems are available, and it is very being used for analysis of say chemical agents in all the spectrum. But chromatography is very much required, and it is very good technique, or we say analytical technique to separate, identify, and quantify the component of a mixture. So it can also be used to separate desired product from other component by reaction mixture. So it's very easily understood that when there is a component or mixture of substances, then also this type of material is being used and utilized, wherein you can easily see the understanding of the chemicals or the chemical agents present in a particular group of sample. Next is the ionic chromatography, again closely related to HPLC, is a chromatography technique used as ionic chromatography IC, where ionic species can be separated, detected, and identified. IC has been successfully used in the US Army Material Command's Verification Laboratory in the analysis of several chemical novagens and their degradation project. As with IC, ion chromatography instruments require power requirements, high purity water, high purity chemical reagents, and for preparation of buffering solutions. Again, for the mixture part also, it is being used. US Army, yes, they are utilizing all these things because they are having this type of technologies long back. So it is also related to HPLC only. Like HPLC as instruments can use spectrometer, microwave spectrometers, mass spectrometers, and electrochemical detectors. These are two figures which you can say focus upon the ion chromatography. It's a group of chromatography only which utilizes all these materials, and similar, the mechanism principles is quite similar to HPLC chromatography technique. It basically known as ion chromatography, where ion species can be separated. And if you get that in HPL, also you can see the detection mechanism and separation. Here also separation, but ionic species are being used as a material sample, and based on the properties of the ions only, we understand or say bifurcate the material or the samples in IC. Some more are capillary zone electrophoresis. Again, capillary zone fluorescence, what we as CZE or CE, is a chromatographic technique that can be thought of as a hybridization of gas chromatography, liquid chromatography, and ion chromatography. So, depend upon the chromatography, we have three: gas, liquid, and ion. So it basically have say hybrid type of thing and can be having all the technique utilization of capillary zone rather than using a temperature gradient or a solvent gradient as in gas chromatography or HPLC respectively. A mobile phase containing an ionic vapor is used as in ion chromatography. So it is quite related to ion chromatography. Same principle applies and lies here also, which focus upon the capillary zone electrophoresis. A high voltage electric field, either fixed or potential as a gradient, is applied across the fused silica column similar to capillary columns used in gas chromatography. It is only used, and persons in the chemistry lab can easily analyze with the data what is there. There are certain portable also which we have discussed in the earlier section, that in portable we can carry on the site with the help of machines or say vehicles, but these are quite established in the labs. Requires we bring the sample from the site, and then we analyze what properties the sample is showing. So it is required in that way. But in normal course, we collect the sample, then we bring back to the labs. It is not always required that yes, go on the site and this thing those samples. So moving the next, there are certain selection factors also. When we see in the chromatograph now, what how to focus upon detection techniques we have already seen, and how to focus which type of parameters is being used for understanding. For example, you as a first responder or a decision maker have to come onto a particular parameters, that how to understand, how to analyze which spectrometer, where HPLC is being used, where IC is used, where Fourier analysis. So you have to focus upon certain parameters. We have seen around 10, 10, 15 odd technologies and the detection tools, but how to use as a common first responders again a bit concern. So we focus upon certain selection factors. It is not say fixed or it is not a mandate, but yes, there are certain factors recommended for consideration by the emergency first responders community when selecting and purchasing chemical agents or toxic industrial material detection equipment. For example, it is not always that you are going to use in on the field, but you want certain priorities. Okay, these are the priorities which we can focus upon, and then only we can focus upon the purchasing of the equipment. These factors were developed so that chemical agents and toxic industrial material detection equipments could be compared and contrasted in order to assist with the selection and purchase of the most appropriate equipment. So we will see one by one which type of factors are being used as an responders, as in decision makers, that you can say or say guide to your fellow colleagues or say system, so that it can be used. So the first factor is chemical agent detected. This is the first factor which we have to use, the description. This factor describes the ability of the equipment to detect chemical agents. So this type of detection is much required. Chemical agents, when referred to this in this guide, refer to the nerve or blister agents only. Blood agents and toxins are included in the list of toxic industrial materials. Nerve agents primarily consisting of GB and VX. Other nerve agents include GA, GD, GF. Blister agents are primarily limited to mustard per H. So you can easily understand this describe the ability to equipment detect the chemical agents. If it is able to detect chemical agent, then only it is of use, else it is not being used. So this parameter we have to focus on factor. Second, TIMs detected. You have detected the chemical agent. Now, second is the factor describes ability to the equipment to detect the TIMs present or not. ठीक है? This is the basic parameter that it can detect chemical agents and it can detect toxic industrial materials. Now, the third is sensitivity. Sensitivity is the lowest concentration of a chemical agent or toxic industrial materials that can be detected by a detector or equipment. This is also referred as detection limit. Detection limit may be dependent upon the chemical agents or TIMs and the environmental conditions and operational conditions. This is also much required that you have to focus upon this particular part that it can be detected. So sensitivity is also a factor which is used and which we have to focus upon without before confirming the concentration. Resistance to interference, and interference we have discussed that which alters the properties or the which contribute to the false alarms. Again, it is in compound that causes a detector to either false alarm or fail to alarm. So if there is interferent type of thing which is continuous swing, we have to also focus upon the interferent part. There should not be an interferent, and it's again a factor of consideration whenever you are going to choose a certain group of say detection mechanism. This factor describes the ability of a detector instrument to resist the effect of interference. It is not that there is mustard gas is there or blister there, and you are your detection mechanism is showing the no variance. The complete detection mechanism will be failed if we are focused upon that part. Next factor is response time. Response time is defined as the time it takes for instrument to collect a sample, analyze the sample, determine if an agent is present, and provide feedback. So response time is much required so that if we are focusing that within a half an hour we can detect so that response golden hour response time can be used and it is responding after 3 days, 4 days. Again, it is much required that this factor should be also considered. Next, startup time factor. The startup time is the time required for setting up and initiating sampling with an instrument. Next factor is detection states. This factor indicates the sample states that an instrument can detect. The sample state includes vapor, aerosols, liquid. That means it should be multi sample based or multi states based. It could be vapor, aerosol, liquid. It should detect all the states. Next is the alarms capability. This factor indicates if an instrument has an audible, visible, and audible visible alarms. It is not that say capability and compatibility, both terms can be very easily used for this factor regarding the instrumentation finalization. Next is the portability, important factor in case of CBRN or say chemical detection. The portability is the ability of equipment to be transported, including any support equipment required to operate the device. Two important things to consider under portability are the equipment dimensions and weights. It is very compact, very easily handled, and the weight is less, and it is very easily carried up on the site. Else, you have to establish a system and mechanism. Then only we can have this equipment. They determine if a single person can transport the equipment or if the equipment requires vehicular transport. So again, portability is a big factor which can be utilized. Next, the power capabilities. Power capabilities indicate whether specific equipment components can be operated on a battery or it require a AC electrical power. So capability is also there. For example, just giving example of a camera. If a camera requires a battery or requires a power connection, then you will preferably go for the battery part because we have to take it to a place where the scenes are available. Similar case of is the power requirements in case of sampling device or detection device. It should be having a specific components. Next is the battery needs. Battery power is the ability of the equipment to be powered by batteries with an operating life capable of sustaining activities throughout an incident. The number of batteries required for operation is also an important consideration. During a incident, you can easily say you have to carry a number of things. So we require this type of instrument which have all these inbuilt provisions. It's not like that you have to carry a number of things. You have to carry battery, then you have to carry wire. It is not. So that the factor of battery is also an important factor. Operational environment. This factor describes the type of environment required by the equipment to operate optimally. For example, some equipment is designed to operate in the field under common outdoor weather conditions and climates, that is extreme temperatures, humidity, rain, snow, fog. So we want the type of detector. It could be workable at any conditions, temperature, water, humid, snow, fog, whatever there, so that any operational conditions should not obstruct the utilization of that particular detection equipment. 13 is the next factor of the durability. The durability of the piece of equipment describes how rugged the equipment is, that is, how well can equipment withstand to handling a steel operator. You never know the incident condition. It could be a war phase, it could be a peacetime phase, it could be a number of things. So it should be a durable in any condition. It should work. Procurement cost, again, it's a big thing for the financial part. Unit cost is the cost of the piece of equipment, including the cost of all equipment consumables. So again, procurement cost should be on the lower side. You cannot say that we are going to purchase a crores of equipment, then only we can analyze the sample. It will not be accepted at any ground. Operator level. Operator skill levels refer to skill and training required for the operational instrument. It should be very minimal. This thing as in layman also, anybody of us can understand. Okay, this is a sample. You have to throw the light, throw the instrument, put the and it will give you a result. So the analysis is very easy. It does not require an n number of analytical say interventions so that we can easily understand. Next is the training requirements. On the last is training requirements is the amount of the time required to the instrument, the operator to become proficient in the operation of the instrument. For example, higher end equipment such as ion mobility spectrometers or the sort devices requires more in-depth training such as specialized classes for operations, maintenance, and calibration of the equipment. So all these things contribute, but training facilities must require. Training requirement should be a factor that it requires minimal training and get output. Say in a training of 1 hour, if you are able to start and utilize the equipment, it is for good. It is good for you. And again, as you know, in case of severe and incidents, time is very much required because incidents are everywhere. So we require such type of equipment which could easily be understandable. So with this, we are going to complete our sessions for the detection, and you can see the training, requirements of factors. If you are able to analyze these factors also, you can easily detect the chemical agents present in the embedded environment. So with this, thank you, Jai Hind. You can send your questions to HBNI, and parallel you can send to me also. But yes, in HBNI, if you write in the box, we can easily give the example. We can easily try to give answers for your questions. So with this again, thank you and Jai Hind.